can be much more than a pollinator-supported ecosystem. That is the fun part of it, and that's the engaging part of it, where the person who doesn't have that connection with nature can just appreciate the migrating swallowtails coming through late July that are just covering your prairie all at once, because no one else has a prairie, so your prairie is the spot of the neighborhood. But there's a lot of life going on underground that's unseen in the prairie, because most of the biomass is underground. I think it's only 1/4 of the biomass is above ground. So most of the biological activity is actually underground as opposed to above ground. And the cool thing about putting this into your landscape, yes, it supports local populations of pollinators within that 3 to 6% of the land. It definitely does that. But the implications are much bigger than the 3 to 6% of the land. We'll talk about this in later slides, but this has a huge potential to be a biomass energy resource, which can be sustainable if after the biomass is burned, the ashes are returned back to the site. Then you're not degrading the soil. But with it being able to produce so much biomass per acre above ground each year, and that being able to be easily processed into these little biomass pellets and biomass bricks, it's just having that as a future energy source that actually supports biodiversity, which most of our energy sources do not support biodiversity. That's huge implications for ecology in the future. Sustainable cattle farming format. So there's patch burn graze, which we'll talk about in the next slide. Excellent carbon sequestration, a medium in which to grow the food forestry crops, and that's really talking about small scale residential, but also big scale. If we're going to transition our soybean, wheat, corn, sterilized format to something that produces food but also allows biodiversity and isn't sterilized, these food forestry formats, or these food forestry crops, which we'll talk about after the prairie, they need a medium to grow within, and that medium is the prairie. And a lot of those food forest crops are adapted to the prairie. So that's a future in which ecology thrives, and we can start that discussion right in our front yards. This is just another view of the tallgrass prairie. We have less than 2% of the original tallgrass prairie type. So if you remember that big gold swath, a portion of that was tallgrass, a portion of that was mixed grass, and a portion of that was shortgrass. The shortgrass is closer to like Colorado. The drier you get, the further you get closer to desert. But the tallgrass is what we had east because we have a lot of rainfall. And we have less than 2% of that remaining because it's been turned into soybean wheat and what's the other, corn, alfalfa, cotton. Well, not so much cotton up here. But with less than 2% of it remaining, this landscape once covered 40% of the U.S.'s land surface. So that's again why ecology isn't thriving. If we take 38% of what represented 40% of our landscape away and we turn it into sterilized formats or too heavily grazed formats, now we have monarch decline. So this system evolved to somewhere between 50 and 65 million years ago. I couldn't pin down a number. The studies were saying different things. But with this intelligence, whenever a system has been in place, much longer than our systems have been in place, like the actual format of agriculture we have right now has maybe been in place for like 30 years or so. The specific format we have at this moment. But this prairie has been in place and sustaining itself without any inputs and sustaining a lot of life without any inputs for over 15 million years. So whenever we're working with one of these systems, it has lessons and intelligence that we can translate into our landscape and into our agricultural system, so we can basically catch up with the times by going back in time. Here's just another view. In the trees in the background, I'm not sure why the savanna starts there. This is in Chicago. But the trees kind of have marched out to that point, and then the rest of it is just pure prairie. And the oak hickory savannas, those are the two of the main crops you would use in an agroforestry system. Acorns are actually completely edible as soon as you grind them into a nut flour, and then you soak the tannins out. Then once the tannins leave, the bitterness leaves, and you just have the flour. So a future where we're planting oaks and hickories and chestnuts as sustainable nut crops in a medium within the prairie that they once grew in that format is a future in which ecology really thrives, and we can exemplify that right in our yards if we have enough space. This is a view of it in the spring. The little blue flowers are called downy wood mint. This is along Miami Whitewater Trail, Shaker Trace Trail, I think it's called. Coreopsis is the big gold flowers, and the white flowers are penstemon. This is really short at this time of year with this association of plants. It's about a little bit over a foot high. And this is midsummer. When you seed a prairie mix, you never really know exactly how the prairie is going to mature, because if you notice higher up on the hill, there's less purple coneflower and more of the yellow, which is gray-headed coneflower. And then lower on the hill, which is actually getting close to a creek, so maybe the soil is getting deeper and it's becoming more of an old alluvial deposit. Purple coneflower is dominating this lower elevation. So when you plant a seed mix and it has like over 40 different species, they sort themselves out based on where they know they should be. They'll be outcompeted where they shouldn't be, and then they'll outcompete others where they should be, which is the intelligence that I'm talking about in the ecosystem. Late in the summer, you get the growth of the taller grasses. These won't mature for about 3 years, whereas the wildflowers mature pretty much in 2 years. This is little bluestem. It's one of the short grasses. The long blades are Indian grass. Having that grass mix, even though it may not be as exciting as the flowers, having that grass mix is a pretty much a essential component to having it look aesthetically nice throughout the whole season. Because when the wildflowers stop blooming, you're not going to go deadhead an acre or a 4th acre worth of flowers. You wouldn't want to do that anyways, because the flowers are going to seed. But with the grasses coming up and providing that green and maroon and wind animated texture throughout the whole season, it gives your wildflowers a structure to complement. So in a sense, the wildflowers are complementing the grasses, and that's what really makes it beautiful in the winter. So this is little bluestem, and the taller stuff that you probably can't see is Indian grass. And then in the foreground is hairy sunflower, which is one you never want to plant in a garden. It even takes over patches of prairie if the landscape isn't very well balanced. And but anyways, this is what makes your prairie a 4-season, aesthetically showy landscape, is having a balance of those warm season grasses that were really the background of the prairie. And this is just another view in the winter. So what we have locally, up in Dayton and up west of Columbus, we have true deep soil tallgrass prairies. And those have more so landscapes like these where there's a profuse amount of flowers, the soil's deep so they can reach their roots really deep, the heights are a little bit taller. You just get a really nice, lush prairie out of that deeper soil, which is most of what we have in Cincinnati too. Then once you go to Adams County, you get these glades, these cedar glades. And these are prairies that are there, and they're perpetuated by the bedrock being so close to the surface of the soil that basically only a few handful of trees can grow. That's eastern red cedars, maybe sumac, a few red buds and hazelnuts. So very small plants in general can grow in the glades, and oaks over time can shade out the glades, but overall it's just a very short prairie type, and that's more of what we have locally as soon as you get into that geology in Adams County. Edge of Appalachian Nature Preserve and ODNR has great preservations of that landscape. But even though the soil is rocky and shallow, way too rocky and shallow for, I'm going to close that blind, way too rocky and shallow for large trees to grow, it still supports a lush prairie when there's a decent amount of rainfall. Now, if we have a very droughty year on these cedar glades, the prairies don't really bloom that much, and you can even see the prairie plants suffering a little bit. And that's just because these are extremely harsh conditions. And that's another view. That one's Adams Lake State Park, so that's ODNR. And same thing, the large leaves are prairie dock, which we'll see, I think, in a couple slides. We'll see the root system of it. And then these trees that are invading the glades are oaks for the most part. So they can't really get very big in the rocky soil, but they can invade the glades. So it's always just a battle, not a battle, just a movement back and forth from oak savanna to prairie glades locally. And that's Chaparral Prairie, which is a great place to see in late July, mid-July. So the way this prairie works and why it's so low maintenance is because, well, if you think about the forest, all of the species in a forest type co-evolve over thousands and thousands and even millions of years to allow every other species to cooperate with them. Sometimes we think of ecology as a competition between this and that, but when you really start looking at the forest, when it's very balanced and it has its keystone species like the bears and the big cats that we used to have, and everything is in just perfect balance, you can see that all the plants, if you look at them individually, they may look like they're competing with each other, but what they do in a complex way is everything is allowed to have its own niche. And it's the same thing with the prairie. So all of these plants, when you look at them and they're like stunting each other a little bit because they're not huge like you would see in a garden, and they have no competition in a garden. In a prairie, when they're surrounded by all that root competition, it's really a cooperation. And so this is big bluestem, which is like the dominant prairie grass, and it can go down to easily depths of 6 feet for those roots, and they're semi-fibrous. And then you have different plants with kind of opposite or differently structured roots that can compete side by side with big bluestem, like prairie dock, which are those big leaves you saw in the cedar glades. And then they send up these beautiful yellow flowers on top of these naked stems without leaves. And then a short grass like prairie dropseed, the roots don't go as deep as big bluestem, but they're more dense than big bluestem, so there's more concentration of roots in that top 4 feet, which allows other wildflowers to find their niche in between that medium of roots. And with everything finding its own place, that's basically why the prairie is so, that's why any ecosystem in balance is so low maintenance and doesn't take any fertilizer, no herbicide. Up front, you have to use herbicide to remove whatever vegetation you have there, like lawn or something. But after that, little to no herbicide and no irrigation. These things are in complete balance with their environment. So the implications of this are huge, which I've already briefly touched on. If you remember, we have this huge swath of grasslands that used to be there and didn't have such high livestock grazing concentration. And then it also went into the east in little patches and little forms of this glades and things like that. If we have, well, looking at that landscape and then looking at this chart, you can see how much the prairies were responsible for sequestering carbon, which has now mostly been released into the air. So about 50 to 70% of our cultivated lands, our cultivated soils, like agriculturally cultivated or ranched or grazed, 50 to 70% of the original carbon that was in the soil has been released into the atmosphere. And that's a big chunk of what's in the atmosphere right now, which has huge implications on ecology thriving in the future. So when you look at these landscapes, you see, cropland, crops, we have big crops, corn and wheat. Wheat has a big root system, and corn is just huge overall. So in the soil, they sequester a little carbon. In total, not much above ground, but in total, it's about 37 tons of carbon per acre. And then when you look at a desert or semi-desert, it's actually not too far behind our croplands at 20 tons per acre. And then you hop over to the wetlands, and because the carbon can't quickly break down in saturated conditions, it's the highest at 306. And then you got boreal forest up north where it's so cold the carbon doesn't process very quick. So they have 182 tons of carbon per acre sequestered between the above ground, which is plants, and the below ground, which is just accumulated, broken down roots and things like that. And then this is where the prairie and our deciduous forest falls. So our temperate forests are about 68 tons of carbon per acre, and which is a pretty moderate amount. And our temperate grasslands actually sequester more carbon than our temperate forests. And that's 108, with 105 being in the soil. So one of the huge focuses of carbon sequestration now is restoring and managing our pastures and grasslands in a format that actually promotes that again and isn't so heavily stocked. And this was the 2015 measurement of average hotter than average global increase of temperatures. Interesting thing about this map is the blue parts are actually indications of warming too, because it's freshwater ice melting into the ocean, creating cool zones. So basically this whole map is showing the heating of the planet. And this is seriously why ecology won't be able to thrive in the way it has been in the future, which is why talking about these grasslands and planting these grasslands in our yards where all these people are so concentrated is so important. With sustainable grazing, I'm not going to go through this very in depth, but basically this format is being studied by Chris Hessler of the Nature Conservancy in Nebraska, where they allow cattle to graze a whole section of the prairie all year long. They leave one section unburned. They have 1 year that was burned, one section that was burned the year before, and then they have one section that was burned like just this past spring, and just this past late winter. And they find that the cattle behave just like bison, where they graze the most recently burned areas because the nutritional content is higher in the vegetation. So if we can, and this is some of the plots, they've actually found that grazing these cattle at light stocks, which means we would have to eat less meat, but grazing these cattle at light stocks, they almost act just like the bison did, and they increase plant biodiversity in these test plots. So that's a format where grazing and animal farming of the future can actually increase biodiversity and, in short, save our planet if we're managing our land in this format and we're not demanding so much meat. The whole Great Plains region, this is another picture, the whole Great Plains region supported 60 to 75 million bison. Today we have 90 million head of cattle. So you can see that this grassland can support, a lot of potentially farmable meat in a sustainable format, like it was in the form of the bison, 60 to 75 million. But in the formats that we use right now, and with the pastures in the formations that they are right now, that's just not happening. And this is just the biomass thing. And this is what your prairie can mean in your yard. Like, these implications are huge for saving ecology in the future. 1 acre of prairie can produce an equivalent energy of 2 to 6 tons of coal per year. It depends on how moist your soil is. And the average American uses an equivalent of 4.7 tons of coal per year if all energy for the house were derived from coal. So that includes calculating natural gas and putting that into how much coal equivalent. And so with prairies having the potential to power the average American home, which we can all agree is in a very luxurious format, then supporting biodiversity locally while actually retrieving a sustainable energy source is that's something that can make ecology thrive in the future. So quick prairie points. They need to be custom designed for your site, factoring sun, exposure, placement, hydrology, and site limitations. Every site is different. Every soil is different. We have glacial till deposits, which are deep clay, acidic. We have them poorly drained. We have them well drained. We have limestone hillsides, which have very shallow, rocky soil from our bedrock. We have all kinds of soils types. And to make your prairie most successful, the seed mix should match the soil type, and whether the hillside is facing south, east, or west, whether the hillside slope is significant enough for that to even matter. All those kinds of things really help your prairie to be the most successful project, because that determines what species you put in the seed mix. There are no direct ordinances or regulations that restrict prairies unless you're in a homeowners association where they can just make up rules. But as far as government regulations and ordinances, there are no direct restrictions. So if you frame your prairie in with like a 6 or 7 foot swath of lawn, that is basically a landscape bed. There's no ordinances against how you manage your landscape bed, how tall the landscape bed can be, or what kind of vegetation can be in the landscape bed. There's no ordinances addressing that. So framing it and leaving lawn around it and framing it as a bed, you can't be touched legally. You may have to have some conversations, but you're within the legal law if you really want to do it. And the prairies change drastically each of the first 5 years. Then it kind of stabilizes, and the changes are more minor unless you burn it or there's grazing, some of the natural things that happen in prairies. So burning is also probably not going to happen within metropolitans, but on the outskirts with different ordinances, there's more lenient ordinances available for burning. It's not absolutely necessary. You're not going to create this remnant quality prairie anyways, because those have upwards to 100 species of grass and wildflowers, but the amount of commercially available wildflower species is probably just around 50 or 60, and then the ones that are actually applicable to your site is probably around 30 to 40. So that's really not the goal, is to have this, every 2 years burn Hamilton County Park quality prairie. It can still be beautiful if you just mow it once a year without burning. And it can still serve that function of promoting the big picture that we've been talking about. It's best seeded mid-October through November, at the latest early December, but that's starting to push it for good spring germination. Later seedings may fail. They have failed for me, depending on the weather of the winter. If you have a really warm winter and there's a lot of days above like 38 degrees, then if you do seed it in January, you can get some germination. But if you have a cold winter, you're going to get like less than 2% seeding it after January of germination. So the best, safest way to do it is just to seed it mid-October through November. And that allows the seed to go through the chemical processes and the temperature processes that happen when they experience moist soil at the fall temperatures. It's called stratification. Without that process happening, then the seeds won't germinate in the spring because they haven't had those inner chemical changes to tell them it's time to go. So the placement of the prairie, the rule of thumb, about 5 to 6 feet worth of lawn in between. My computer just died.